So for the first one, BC is congruent to DC. That's given. So I always mark that in my diagram. BC is congruent to DC. I'm also given AC is congruent to EC. That is also given. So AC is congruent to EC. And there's nothing else that I'm given here. Now, I'm going to remind you that when you're asked to show that parts are congruent, you need to first prove that the triangles are congruent. So you look for two things when you're proving triangles are congruent: reflexive property, but also vertical angle. So I know that those two vertical angles are congruent, so I know angle BCA is congruent to angle DCE, vertical angles theorem. So that gives me enough information to say triangle ABC is congruent to triangle. Now A corresponded to E, B corresponded to D, C. And that's going to be by side, angle, side, because the angle is included. And once you prove that the triangles are congruent, well, I know that angle A in one must be congruent to angle E in the other because those triangles are congruent. So that's where that CPCTC comes from. So, same thing here. I had already done this one, so I'm just going to go through. You have your givens, okay? Then your vertical angles. This one was angle, side, angle, and then also CPCTC, so corresponding parts for that one as well. Number 3, this one's a little bit more complicated. I'm actually going to move this proof up a little bit. Things got a little goofy with this. So you have my statement, then I have my reason, okay? So the first thing is T is the midpoint of ME, okay, and that's given to me. I really can't do much beyond that. I can't write any congruence, but if I do know that T is the midpoint of ME, then I know MT must be congruent to TE. Okay, and that's because of the definition of midpoint. Okay, I look at my other given. I mean, you guys don't have to do it in this order. You can put your givens first and then come to your conclusions. You're also given angle G is congruent to angle J. Also given to you. I don't have anything else. It's very popular for this homework assignment. Well, I also know that my vertical angles are congruent. So I know angle GTM is congruent to angle JTE. Okay, and that's going to be vertical angles theorem. And so that's enough information to say that triangle GTM is congruent to triangle JTE. Okay, and that's going to be by angle, angle, side. Once I know that, I'm trying to prove that T is also the midpoint of GJ. If T was the midpoint of GJ, then these two parts would be congruent. So the opposite also true. If both of those parts are congruent, then T has to be the midpoint. And I know from all of my information up here that GT must be congruent to JT because corresponding parts of congruent triangles are congruent. Knowing that, then I know that T is the midpoint of GJ, okay, and that's going to be by definition of a midpoint. So that's number 3. Number 4 goes easy again. You know D is congruent. You know angle D is congruent to angle C. You know CA is congruent to DA. Okay. And then we have our vertical angles. I know EAD is congruent to BAC. Again, another vertical angles theorem. Very popular vertical angles. So I know that my triangle is triangle EDA, let's say, must be congruent to triangle BCA. Okay, by angle side angle. And that said, then if I know the triangles are congruent, I know EA must be congruent to BA, because corresponding parts of congruent triangles are congruent. Number 5, I know AB is congruent to CB. That's given. I'm also given BD bisects angle ADC. So BD bisects this angle right here. If that's true, okay, so that's given, then I know this angle and this angle have to be congruent. I know angle ADB must be congruent to angle CDB. Definition of bisect. Now I have, oh geez Louise, see I wrote ADC, it should be ABC. So again, I apologize for that one. I know that angle ABD must be congruent to angle CBD. So I have this mismarked and I apologize for that. It's actually this angle, I just read it wrong really quickly. So it's this, it is this angle, this part, and this part. Okay. So we have a side, we have an angle, and then you also realize that this is congruent to itself. I know BD is congruent to BD because it's the same side. That, of course, is good old reflexive property. And if that's true, then triangle ABD must be congruent to triangle CBD. Okay, and that's going to be side, angle, side. If that's true, then I know that this angle and this angle have to be congruent to each other. I know that angle ADB must be congruent to angle CDB. Okay, that's because corresponding parts of congruent triangles are congruent. Knowing that, because those angles are congruent, then BD must be a bisector, because those angles are the same by definition of bisect. So BD bisects angle ADC, and that's my definition of bisect. All right, last but not least, we're using our parallel lines. Move this up. You guys have the capability of doing that too. Okay, so you're given CB is parallel to ED. That's given. I know if those are parallel, I know angle C is congruent to angle D. Because they're alternate interior angles on parallel lines, so alternate interior angles theorem. I also know, I mark this with a different color because they're different angles, angle B must be congruent to angle E. Also alternate interior angles theorem. Now I could use vertical angles, it's not going to be particularly helpful in this case. I have my other given, I know CA is congruent to DA. That's given. So that tells me that triangle ABC must be congruent to triangle AED. Okay, and that's going to be by angle, angle, side. If those triangles are congruent, then the parts are congruent. Then BA must be congruent to EA because corresponding parts of congruent triangles are congruent. And that's that.